James Webb Space Telescope makes surprising discovery of what city lights look like in space. 7 billion miles away in the world, this unexpected discovery led to the need for the bear for life outside. The telescope focuses on Proxima Centauri b, the closest planet to our planet, and shows the unusual bright lights it emits. What is the origin of these city lights on Proxima Centauri b? Could they reveal life beyond our planet? Join us as we explore how the James Webb Space Telescope identifies these wonders of space. Scientists and the general public have been predicting and researching a picture of a world outside the solar system for years. Any evidence that can be found to support the space fantasy is widely accepted. Recently, the scientific community was amazed when the James Webb Space Telescope found the most visible signs of life in space. As it probes space and transmits important information to Earth, the telescope sees unusual city lights shining from the exoplanet Proxima Centauri b. These lights, as the name suggests, seem to illuminate a distant city. The possibility of an alien city on this star surprised scientists. They are confused because this may be the discovery they have all been hoping for. If this is true, there are many possible beliefs, which means that there is an intelligent life form that is creating aliens in space, and we are just beginning to see it. When NASA engineers saw city lights 7 trillion miles from Earth, they couldn't help but wonder how long these lights would have been illuminating space, waiting for human development, to technology to find out. Astronomer David Keeping of Columbia University describes the exoplanet Proxima b, where city lights have been spotted, as difficult. He pointed out that this star system, the closest to us, has different heating patterns than other planets. Ordinary rocky planets absorb the sun and emit infrared radiation, but this is not the case with this infrared planet, as the infrared spectrum of the planet is different from that of the host star and Proxima Centauri. This is a good feature for the observations of the James Webb Space Telescope, which is good at detecting infrared wavelengths thanks to advances in the telescope's infrared imaging capabilities. Proxima b's unique thermal signature will play an important role in unraveling the mysteries of the planet's atmosphere. Scientists are planning to use the James Webb Space Telescope to unravel the mysteries surrounding Earth's atmosphere. They also plan to use the telescope to assess the possibility of habitation on this exoplanet. James Webb Space Telescope will study what's going on in the night side of Proxima Centauri b. Picking up tiny rays of light in space is a challenge for telescopes, but not for this one. It is possible to see very little light from outer space. This is a great tool to confirm if the suspicions about the city lights around Proxima's night side are true. Artificial light from the universe is visible to the naked eye as it is in a frequency band 1,000 times narrower than starlight. Proxima b has a good correlation between its stellar properties and surface interactions. On the sun side of the exoplanet, there are many solar panels that absorb the energy of the bubble from the star. Its lens also reflects incoming light rays. At the same time, as Proxima b completes its orbit around its host star, Proxima Centauri, it will experience day and night cycles, with hot days during the day and cool evenings. This planet is known to have varying temperatures determined by its composition. For example, if Proxima b had no wind, the difference between day and night would be very large. Without the moderating influence of the wind, the temperature on the day side would be very high and the night side would sink into cold darkness. The sign of the temperature difference is an important question for astronomers seeking to gain a deeper understanding of the composition of Proxima b's atmosphere. Monitoring global temperatures to provide accurate information. Its atmospheric properties. Interestingly, the James Webb Telescope's orbit around Earth coincides with the orbital period of Proxima b, allowing for a comprehensive observation of its 11.2 solar cycles. If Proxima b has an atmosphere, the next step is to analyze its atmospheric chemistry to determine if it can support life. The most important signs of life are the presence of gases such as oxygen, water vapor, and methane. If these elements are found on this planet, it is a sign of living conditions. To successfully determine this, scientists must be very precise in capturing and observing the light beams traveling through the planet's atmosphere. This is a very challenging task, despite the James Webb Telescope's ability to reveal planetary features. Despite its power, the telescope is not limitless in its capabilities and can only look at some of the closest planets in the universe for atmospheric research. Astronomers are now looking to ground-based observatories, such as the Very Large Telescope, ELT, which will begin operations in 2028. The ELT will probe deeper into the atmospheres of distant exoplanets and their production data that provides comprehensive and transparent view. Their home screen. NASA scientists and the public alike look forward to the launch of such wild space telescopes. Until then, the James Webb Space Telescope will be an important tool in our quest to unravel the mysteries of distant exoplanets. Despite its current limitations, the telescope can provide deep insights that could revolutionize our understanding of the science of planetary observation. Scientists have a goal for future telescopes. Reduce the amount of bright light emitted by a planet's star, so that astronomers can better see the moon reflected from the planet itself. They plan to do this by using internal masks or large external scattering like satellites, similar to using hands to block out the sun to see something more clearly. The dramatic decrease in brightness from the host star will allow future telescopes to study faint reflections of light from a distant exoplanet, providing a more detailed analysis of its atmosphere and life. However, this approach has its challenges. Scientists must distinguish between gases produced by biomass and gases produced by natural processes such as volcanic activity. Astronomers are trying to understand the characteristics of exoplanets, to better identify the signs of life and to isolate the positive effects. The James Webb Telescope shows the scientific advances made in exoplanet research and previews amazing discoveries that have never been made before. As we expand our knowledge and explore the world, we are better able to understand the complexities of the world and our roles within it. After exploring all the planets in space, and despite decades of searching places for signs of life, scientists have yet to find a planet that could harbor life. Shaker continued. Are we alone in the world? For millions of years, throughout the human world, people have wondered if they were alone in the world. This long-held dream continues. Even now, scientists have the James Webb Telescope in outer space attempting to detect alien civilizations hidden among us, while studying various planetary bodies for signs of life simultaneously. A popular narrative has recently emerged suggesting that some extraterrestrial beings might truly be present in the stars, patiently waiting for humans to discover them. To answer this inquiry, two American astronomers, Jill Tarter and Thomas Pearson, launched a venture called the Search for Extraterrestrial Intelligence, SETI, in 1984. Known as the SETI Institute, this nonprofit endeavor aims to analyze cosmic signals to capture radio transmissions from space. The emphasis on radio signals stems from their ability to traverse vast distances without being dispersed or absorbed like other forms of radiation. Because of this, radio signals may be detected by the 42 radio telescopes that make up the Allen Telescope Array, located in the Cascade Mountains of California. Despite the SETI Institute's efforts to monitor for signs of extraterrestrial life, no such transmission has been found in over 3 decades. Jill Tarter is very optimistic about their hopes for a positive discovery, and wants to encourage people around the world to take part in the opportunity for international cooperation. The hunt continued until NASA announced that the James Webb Space Telescope had detected artificial light from a near-Earth planet. The James Webb Space Telescope was the first instrument used by humans to gain deep insight into the mysteries of the universe. Launched in December 2021, this telescope is known as the first human-made infrared telescope. With advanced optical technology, this telescope can penetrate the dust of the sky to reveal the mysteries of the universe. The main goal is to study the formation of galaxies and the first stars that appeared billions of years ago. A telescope is a special set of instruments that work well to provide views of the universe. It includes a near-infrared camera, a proximity sensor, a mobile device, and a smart sensor that helps keep it in the right position. The telescope's large mirror, made up of 18 hexagonal segments, is carefully designed to capture faint light from the world's most distant galaxies. Operating at extremely low temperatures, it can detect subtle heat emissions from distant objects. Since its launch, the James Webb Space Telescope has lived up to its promise by revealing some of the most distant and oldest galaxies ever discovered. The powerful instrument has provided new insights into star formation, galaxy evolution, and planet formation. The discovery of city lights on Proxima Centauri b is a groundbreaking discovery that adds to the growing body of evidence for life outside our solar system. Although more research is needed to confirm the nature of these lights, the methods are important. Scientists are always eager to find new ways to understand the complexity of the universe. As we continue to search the world for signs of extraterrestrial life, One thing is clear. We are getting closer to answering one of humanity's deepest questions.